Xin chào, everybody. Did I pronounce correctly? I know it's going to be a long day. I'm going to make it 30 minutes, and I'm going to be precise what I want to deliver. My name is Ettikan. I'm from NVIDIA. How many of you play games, video game? Okay, there's quite a number of guys who have been playing video games, right? So I'll share with you how NVIDIA has actually transformed itself from a video gaming company founded in 1993 by Jensen. And we are a Silicon Valley-based company who focused a lot in video games when we started. In the last 25-6 years, we have transformed from a video game company today, world-leading AI chip maker. Now, I work with many developers from companies like FPT, very interesting startups, and also universities like FPT universities who actually does research in a specific area. I'm going to share some of the use cases that I've actually gathered, not only within this particular region, but worldwide, how AI today actually transforms and increases productivity across different sectors. I think the previous presenter has shared very well in terms of what is AI and how AI is impacting the entire world. Now, let me share with you a simple use case. So today, if you can see over here, if you have the algorithm has been implemented, you can take a photo in a specific area, you can take a picture, and from this picture, you can link it with the AI technology, where we call it neural network being applied, straight away to a marketplace. And this marketplace, you can search any product which is very similar. And with this, it actually increases the reach out of your marketplace that you have with a high level of accuracy, very similar product that you're looking for. And of course, with this good model that you can develop, you also can check counterfeit products, right? So AI, with this example, actually transform how you can do your business much better with a finger click. Now, next look at it. A very important part that I want you to take away is, in order to solve a problem using AI, you must first understand what is the AI problem that you're trying to solve. I'm going to share, since I work with many companies and I have an NDA, so I may not be able to disclose some of the production use cases, but I just took a paper which has been published, so it's publicly known paper. I'll share with you how the entire process flow of AI takes place for a smart city. So this is a license plate recognition, LPR we call it, right? So in this case, I want to recognize a character. So this is your workflow, how the entire activity of recognizing a specific character to be done, what I call as a workflow that you have. This part of the component can be implemented using AI techniques. It could be Inception, it could be Google Ad, it could be Lean Ad or VGG, any type of the neural networks. You must identify what exactly can be done by using AI, and the other one is normal flow of AI or workflow of AI. By knowing this, you carve out the particular feature. It's what you call region of interest. If you can go out there, there is many demos talking about region of interest. You carve out the region of interest, and you can use, for example, CNN, one of the techniques. You can combine with other techniques, and you can have your own algorithm to take what you call voting mechanism to select, not to select certain information. Now, having this put together, this is an example how a CNN can be applied. Now, as far as that we have gone through now, a lot of neural network models are publicly made available for you, free. You go and search GitHubs, a lot of model can be downloaded. It will be pre-trained with a certain level of accuracy. May not be as what you want, but at least pre-trained with 80% of accuracy. Now, using such kind of model, by using a deep neural network layers, what you need to do is you need to understand. So this is where NVIDIA graphics card, which has 5,120 CUDA cores, together with AI chip, what we call as a tensor core, together understands every pixels and does the prediction or analytics and share with you what exactly the number plates are. So this gives you the level of accuracy that you want to solve when you're looking at a car or a bicycle or a trishaw or cow, whatever runs on the road can be identified. Now, this then, you subsegment it and you form it together, and based on the segments of blocks, you understand the LPR. It's just an example which I want to share with you how real AI algorithm being implemented in license plate recognition. Same mechanism, same methodology being applied in many sectors. So from our experience, AI cities becoming very important. In Vietnam as well, if you can see, smart city is a very important area for everybody. Public safety is another area that we see for security purposes. Next, what we see in terms of healthcare. Throughout the world, it's a multi-billion, if not trillion-dollar industry where 3 million medical devices going to have AI built in to understand, to interpret, and to advise the doctor to do the job much better in accurate manner. Startups, we see many startups are being born, and if you can see in US, almost a few hundred billions of dollars gone into startups where they focus a lot of in AI development. And we also we see a lot of work being done in industrial space in terms of robotics to automate certain kind of processes where manual job, which is very rudimentary and very time-consuming and boring work, can be given to robot to do. And finally, transportation. As I know, FPT software, FPT has one entity where they're actually looking at AV vehicle. For NVIDIA, we are the world-leading company provides AV solution. Later, I'll be sharing with you how we've invested heavily into this. Now, given these 6 areas, an example, I'm going to pick 2 areas just for our sharing and discussion. One is AI city, and the other one is going to be autonomous vehicle area. So in terms of AI city, by 2020, there will be more than 1 billion camera will be deployed. Now imagine every camera could run 30 frames up to 60 frames based on needs and deployment area. Going to send, if it's going to send a full HD picture back to the data center or to be analyzed front end, how much of data it's going to generate. Now, we need algorithms which are written by software guys like you, which has a high level of accuracy to remove noises. The noise could come from harsh environment. In this case, could be snowy environment. It could be rainy, or that could be a haze, or different type of environment where we need to eliminate. Now, next is, if you can see, deep learning has actually surpassed human capability to understand, perceive, and tell us the meaning of an video image or video stream. So with this capability, for example, over here, a normal camera that plugged in the high pole in a cross junction can automatically recognize many information. These are not very difficult to do. Today, by using a deep stream SDK by NVIDIA, a normal AI engineer can do it within 2 to 3 weeks maximum, this particular software. But now, as soon as you extract the information, what do you do after that is very important. So you know number of people who are walking. You can do density. Then you can do a heat map. You can do a plot graphing of people who are actually crossing certain particular area. That is standard analytics that you can do by using normal machine learning techniques or deep learning techniques or statistics or different kind of techniques can put in. But the most important is how do you abstract out information or knowledge captured by video or image. That is being done by using all our software. This is an example. Next is you can do beyond real time. You want to do post analytics. So in this example, I have a camera, static camera in this particular angle. I have a software which I can tell all the bicycle which turn right and show me those bicycles, right? So this is how you extract knowledge, you extract information from the data streams, video streams that you gather. Just analyzing video alone, it is not sufficient. But how do you extract information? You interpolate that information with some other information that you extract from other data sources, could be text, voice, and so on, gives you better meaning for you to analyze and to make certain kind of decisions. Now, we also see a lot of examples how in a large city where in this example, one man who had dementia, he kind of lost in the city. So within 30 minutes, using hundreds and thousands of cameras that they have, they actually find the location of this guy, and they actually united the father to the daughter together. This is another example how AI actually helps to solve human problem. Next, if you look at it in terms of city resources, this is an example where they use video cameras, which is positioned at the entrance of the vehicles where we go in, and for parking bay. They can now count number of cars by understanding number of number plates. You can know the density of utilization of the parking lots, and you can make the parking lots something like Airbnb. So where you can sell your parking lots ahead before people coming into a city. So it actually looks at in terms of car management for city spaces. And this is another example where you want to do post-analytics of the data. So in this case, you want to search similar objects. It could be person, it could be vehicle, it could be something else, right? So you store large amount of data sets in your VMS, video management system. And this could come from city camera, it could come from a certain building, or it could be in a retail space, and so on. And you go to a specific object that you are interested, you click on this, you can do similarity search of the particular object. So the AI is capable to understand at pixel level, this object is similar to another object across large amount of databases, which is linked up together. In this example is a car, which is a similar car seen across different area so that you can do a search. Now, next I'm going to share with you how NVIDIA actually invested almost $3 billion in the space of autonomous vehicle. This is one of the cutting edge area, and this is a $10 trillion industry worldwide. And we believe in next 10 years, the way that we perceive transportation, the way that we consume transportation, the way that we use transportation will change. So in order to do this particular challenge is not easy. We need to collect a lot of data. We need to train a lot of models. We need to simulate, because it is impossible for just sending out 3,000 cars or 4,000 cars. We can capture all possible combinations. Like today, I took a taxi ride from a hotel to here. When I gone through, there is so many people, so many buildings, so many activities along the roadside. There is a different type of shops, different type of advertisement, different type of signboards, and so on. It is impossible for us to collect all combinations possible. So we need to simulate this. Next, sometimes we do re-simulation. Finally, we need to do a mapping of the data that we create so that the autonomous car can drive easily on the road. Now, how do we do a simulation? For example, in this case, let me run the video clip. So over here, if you can see, do you think this is a real environment? What do you think? Is it a real environment? What do you think? Right? This is not real environment. This is the whole thing has been simulated, including the sun. I can change the sun from right to left, left to right. If you can see over here, the car is moving, right? There's a reflection of the car on this particular car. That is being simulated, right? If you can see over here, the shadow of the lamppost is being simulated. In a finger click, I can change day to night. I can even simulate the light that being introduced under the pathways. The intention is we want to simulate all possible scenarios, which can go into trillion type of scenarios when we want to test and evaluate our neural networks or AI algorithms, which will in turn deploy on the vehicle which will drive. right? So these are the work that we do in NVIDIA labs, in NVIDIA Research Center. And we are working closely with quite a number of countries in this particular region. For example, Singapore going to start the first trial of autonomous bus end of this year. And by 2020, they will have autonomous level 5 vehicles on the road, and leading to many type of car vehicles, including bus, trailers, and so on. Now, how do we do this? What we do in terms of workflow, this is the work that we do. We collect large amount of data set. Now we validate, we verify. Some data set may not be accurate. We need to clean that. And then after that, we actually, we have our own drive platform. We call it Drive Pegasus, where those data sets in turn being tested. And we have a data factory. So data factory, we have people who actually does logging and tagging these particular data sets, which in turn being used to train on NVIDIA DGX, right? So we train on NVIDIA DGX, and after that, one is validated for a specific environment. Next, we will deploy this particular neural network on the car. Again, in the autonomous vehicle, it's what we call fusion of technology, where multiple neural networks, multiple inputs, it could be LiDAR, it could be radar, it could be GPS, it could be cameras, which is coming in all forms together, where all the neural networks fuse to make a decision. Only 4 simple decisions. Either I accelerate, I brake, I maneuver, or I can steer the direction that I want to, right? So that is being done. And a very important message that I want you to take away today, after all the talks that you're going to attend, is this: data is the new source code. Why data is the new source code? Because the knowledge which comes from the data is what being used by the neural network to train its weight. So indirectly, the data will drive how the network being designed, how the parameters are being changed. So that's why in many of the AI-related research and work and publication, if you can see, data becomes very crucial. So if you have not such good quality data, your neural network accuracy will be low. If you have very high quality data, you have a high quality of network results that you will get. Now, the way that we do in terms of work that we do in AV, we collect the raw data. And for example, if you look in terms of having for single vehicle, we collect about 100 petabytes of data from our test vehicles. Then we have 110 billions of images that we will take it from the data that we have collected. And 20 to 50% of the data may be useful. The other 50% or 70% is not useful. We discard them. We have 1,500 people who are actually doing labeling per month for the images that we collect, so that we have a high accuracy of data that we can use to train our neural network. Again, data is the new source code. So we have 10 plus neural networks, which in turn being used to train. So the cycle is the same. Get the data, train the data, we adjust, we deploy, we test. And it goes through the same cycle. The same thing that you do even for your camera, for the city that you're going to deploy. You got to do this in a continuous manner. It is not one-time deployment, but you have to continuously update the neural network for accuracy, for different interests that you have. And as I shared with you, simulate and re-simulate as well. And from our experience that we are doing, right? So we have 3 million labeled images, and we take about 1 DGX to train 300,000 of labeled images for one neural network in one day. So that means I need about 10 neural networks required for self-driving car. So that comes to about 100 DGX per car, which I need to train so that we have a high accuracy neural network model. This is how in NVIDIA we train our neural network for autonomous vehicle. Now, the reason why GPU is become very popular today, it is because of the compute architecture that we have surpasses beyond CPU capability. By 2025, GPUs will be 1,000 times much faster than CPU. So this trend is keep we are keeping up to the trend. And if you can see, our latest card is what we call Tesla V100. It has 3 cores within the card. One is the GPU core. We have 5,120 GPU cores which can run in concurrent to train your neural network and to pre-process the data, to get the data ready. That is what we call GPU core. Next, we have a video core for encoding, decoding, any type of pre-processing of the image is being done by the video core. The third core is what we call tensor core, which is for tensor computation or neural network computation. So this is the first world chip that the world has seen combine 3 cores together, the video core, the tensor core, and the GPU core into a single chipset. It can give you, if you look at it in terms of full precision, 32 bits, 15.7 floating points operations. So if you put it into a box with a 16 GPUs, it can give you 2 petaflops of AI computation power that NVIDIA has done. And you can see the trend of compute capability of this. From 15 days using CPU to do computation, you can do that within less than 6 hours by using only single V100 card. That's how we are pushing the limits. This is like a hockey stick going upwards. Now, why GPU is becoming popular is not only because it is compute-intensive architecture, it also can save your space. Only 1/20th of the space required for same type of computation can be done by CPUs. It only consumes 1/22 power that you need to do the same AI computations. So besides doing more work, it saves power, it saves energy. And of course, it saves your money as well, because you can buy more and you can reduce your cost. So by using 140 CPU servers, the work that being done can be done by one single DGX server. So that is the amount of compute that DGX is bringing, or GPUs generally, to all AI compute developers, researchers, and beside AI, it also can be used for traditional computation. It could be any type of computation that you're working on. Later, I'll be sharing with you some other examples. So, if you can see over here, we provide the hardware, we provide the entire software libraries and framework, and it goes cut across different industry. AV, vehicle is only one industry, healthcare is another industry, smart cities another industries, and so many industries are today using AI. And finally, it goes to applications. So NVIDIA we do not develop applications, but we work with partners like FPT, who in turn develop application for end user usage. Now, we have many type of GPUs that you can use, from the server range, where you use it for training purposes, all the way to deployment. For example, embedded system uses Jetson, and the data center uses different type of cards. For example, P4, V100, or P100 that you have. Now, some of the selected use cases can be very fast. For example, cyberspace security. So AI, one of the company called Data Instinct, they've actually can achieve 99.8% of accuracy in terms of preventing the threat, not detecting, preventing threat by using AI and using GPUs. So this is another example done by Accenture, where they use our GPUs to understand all the malicious packets which coming into the network, and understand the packets in terms of the intention of the packet, because as they arrive in a different time frame, in a small packets, eventually they combine together to make a malicious application. So how do you understand, how do you know this is a malicious packets, even though they come in the different pieces? That can be done by AI, by looking at the trend of the packet coming in. Next is another company called Ole. I'm not sure whether the SK2 product is very famous here. You can ask the beautiful ladies, they may know. So Ole is a company which actually produces skincare products. So they actually developed an application, AI-based application. You install these particular applications, it can analyze your face and recommend to you what is the best product to use. By using this, Olay actually has increased or has about 94% of the women who tried this particular application, they buy Olay products. So AI actually ensures the user understands the product well and they buy. Here is basically auto-tagging of the apparel where the person is wearing. So this can be used for advertisement. It could be used for different type of online application. And this is an example where in terms of telco specific, today telcos gather large amount of data set in their base station, Node B, RNC, switches, routers, and so on. But all this precious data, most of the time being flushed, not being analyzed, not understanding the problem the customer have in terms of call drop, in terms of the poor quality of connection. All this data actually available in the network packets and also the data log which is available in all the network nodes. So what telecoms companies are doing today, they download this particular data, they use AI and neural networks to understand the packet behavior and see where there is a lot of packet drops being done. So in this example, Verizon works together with NVIDIA. They've actually shared in one of our GTC how they try to understand the behavior of all these network devices, AI being used for this particular purpose as well. So this is another example of logistic management. We work together with the Connecticut and United States of Postal Service, where they have about 200,000 of mail delivery, where the van goes to deliver the mail. So they use deep learning techniques, AI techniques, plus traditional GPU accelerated query analytics techniques to do path optimization. So they've delivered 1.5 billion pieces of mail every year, and they actually could reduce the time taken to deliver the packages. Next, you look at it in terms of sports analysis. National University of New York University over here, we work closely. We understand for every image that is being displayed, the advertising company want to understand how long certain information, for example, this is the advertisement being displayed in the live broadcast to the TVs, how long each of the broadcasting companies displaying certain paid advertisement. So that being analyzed by using deep learning. Next, if you look at it in terms of industrial use cases, this is an example that has been implemented as well for oil and gas company, where they want to understand the behavior of each and every component of the data sets. One of the example over here, we work with one of the large auto industry. They have about 1,500 sensors in one of the machine. So they want to accumulate all this data over a period of time and try to understand productivity of this particular large machine, where the 1,500 sensors will give us particular information. So AI being used even in the industrial scenario. Next, you look at it, for example, Alibaba receives 8.3 billion translation requests. That means translating from one language to another language. This is what I call humanly impossible task. In no country you can have people sitting behind and translating one language to another language, because you have 8.3 billion requests in a day. So they can translate the request with a very high level of accuracy to operationalize their delivery services or online particular business. I'm sure similar cases are being done in Vietnam as well. So this is another example in terms of healthcare, where AI neural network can be trained to detect with a high level of accuracy some cells which is actually going through a mutation process to become abnormal cell. Eventually, it may become a cancerous. So by using an AI, they have a very high level of accuracy detecting some component of the cells, and they also use genome analytics techniques using GPUs for high level of mapping and matching specific cells. And this is another example of skin cancer. So this is with the Stanford University. They have pre-trained the neural network to analyze different type of melanoma cancers on the skin. And by putting that into this particular device, you just take a snapshot on the skin, it can automatically detect this is potential cancer, and it can classify what type of cancer easily. You don't need to have a skin expert to go and look at that particular skin. It can be done by using this particular device where they have implanted the AI algorithm. Now, this is in terms of one of the use cases in Europe, Britain, where today robots are being trained to help people who are doing packaging, because it was said in next 5 years, most of the shopping going to be done by online. And since being done online, those objects or the item that you buy need to be delivered to your house by different kind of means. So you need to have an efficient mechanism to get that product, package it, and get it delivered to your house. So AI being used in terms of expediting, picking the right object, going through the right place, so that the whole process can be automated in an efficient manner. So with that, thank you very much for your time. This is use cases for AI in industry in a glimpse. Thank you very much.
Vâng, xin được cảm ơn tiến sĩ Ettikan với phần trình bày vừa rồi của mình. Thank you very much for your presentation today. Và sau đây cũng xin được trân trọng kính mời CTO của tập đoàn FPT, anh Lê Hồng Việt sẽ lên trao tặng một phần quà. Vâng, kỷ niệm chương của chúng tôi cho tiến sĩ Ettikan.
Thank you for this.
Vâng, chúng ta cùng dành một tràng vỗ tay thật lớn nữa để cảm ơn phần trình bày của tiến sĩ Ettikan. Thank you very much.